Now let's take a closer look at how to deploy IaaS solutions in Azure SQL. One of the most common reasons for deploying SQL Server in an Azure virtual machine is to support a straightforward migration path from an existing on-prem SQL Server environment to the Azure cloud. This approach is especially useful when you need to maintain compatibility with older SQL Server versions or require full control over the operating system and SQL Server configuration. Deploying SQL Server in an Azure virtual machine gives you the flexibility to configure the environment to meet your specific workload needs. However, with that flexibility comes responsibility. As a database administrator, you need to carefully plan and configure key aspects such as VM sizing, storage, performance, and networking to ensure your SQL Server instance performs reliably and efficiently in the Azure cloud. Understanding these deployment options and best practices is essential for a successful migration and long-term operational stability. In this section, we will look at some of the basic features of SQL Server in an Azure virtual machine. We will give a high-level overview on how to provision and deploy it, with more specifics on this topic in a later section. We will start the conversation on some aspects of this performance, security, and its high availability and disaster recovery options. More on these topics in later sections to come. The Azure SQL platform offers a flexible family of cloud-based services built on the trusted SQL Server engine, making it easier to migrate and modernize your data workloads. Whether you need full control, high compatibility, or a fully managed experience, Azure SQL has an option to match. SQL Server on an Azure virtual machine, or IaaS, gives you a complete control over the OS and the SQL Server instance, and it's ideal for legacy apps or custom configurations, though it requires you to manage maintenance, backups, and high availability. Azure SQL Managed Instance offers near full SQL Server compatibility in a managed environment, making it perfect for lift and shift migrations with reduced operational overhead. Azure SQL Database, on the other hand, is a fully managed PaaS solution designed for modern cloud-native applications, offering you built-in scalability, high availability, and minimal admin effort. For hybrid and multi-cloud environments, Azure Arc-enabled SQL Server extends Azure's management capabilities to the SQL Server instance running outside of Azure, whether on-prem, at the edge, or even in the Azure cloud. With Azure Arc, you can also centrally manage your entire SQL estate from the Azure portal, really gaining visibility and governance and consistency across your deployments. In short, choose Azure SQL Database for simplicity and scalability, managed instance for compatibility with less management, and SQL on an Azure virtual machine for full control that you may need. Resources can be deployed using any of the methods shown here. The Azure portal is typically used for one-off deployments or when you're just getting started. PowerShell and Azure CLI can also be used to deploy resources, but the most powerful and comprehensive method for automated deployment is using the ARM templates. We will discuss more details around this deployment in a later session. Utilizing the portal is quick and easy for a single deployment of a virtual machine in Azure. However, it isn't easily repeatable from the portal, and you must use ARM templates or scripting languages like PowerShell or CLI if you want to automate. The Azure portal is, however, a really great way to start deploying because it offers step-by-step instructions for deployment. It will also create a deployable ARM template for you based on the steps that you use to deploy your Azure resource. This template can be viewed, deployed. It can also be used to help you learn how to create an ARM template. Using PowerShell or Azure CLI for deployment are both using an imperative framework, which means they indicate a specific order of operations to execute. And that means you have to make certain that you create the objects in a particular order. For an example, if you'd like to create a virtual machine, I need to make certain that I first have created a resource group, a virtual network card. I need to also have that network that I'm going to get connected to. I need the storage. And all of this has to be done in a particular order for me to be actually able to create that virtual machine that has the NIC that can connect to the network. So there's a lot of order we need to consider. So this process is critical. And I need that in order to use PowerShell or CLI, since there's dependency relationships that it's looking for you to be able to create it. This method is not as feasible as using the ARM templates, but it does allow you to use those scripts to deploy repeatedly. So if you're not familiar with how to script an Azure deployment using PowerShell or Azure CLI, there's many primers out there that are available for you to use. And you may also consider using Copilot to create the script for you by using your own natural native language to describe what you'd like it to deploy. So that's a really good option. So this is a great way for you to get the script done really effortlessly. Azure Resource Manager templates, or ARM templates, let you deploy your entire Azure infrastructure declaratively. This is including VMs, the network, the storage. Templates will ensure that they're consistent, that they're repeatable results, that it can handle resource orchestration also for you, which is helpful. And we could have it automatically deploying interdependent resources in the correct order and in parallel where it's possible. So you don't necessarily have to tell it the order, you just tell it what you want to make and it can handle the order for us. All of this is built in. It does validation, it's modular, it's reusable. It has instant support for new Azure services. And then deployments are tracked in the portal, enabling us to be able to audit it, to review it, to see what went right or wrong with it that we might need to fix. The ARM templates also integrate with Azure Policy for governance. It supports Microsoft Blueprints for compliance, and it works also with our CI/CD tools for automated releases. You can export these templates from existing resources and author them in Visual Studio Code if you'd like, with helpful extensions available. The template has the following sections. It has a parameter section, which provides values during deployment that allow the same template to be used but with different environments. It has a variable section that allows you to define values that are going to be reused within your templates. You can also have it construct the parameter values for you if you'd like. And then we have a user-defined function section that you can use. These are created customized functions that simplify your template if you'd like to use them. There's resources that need to be specified to deploy. And it also has an outputs section that you can use that will return values from the deployed resources. So more on a lot of this a little bit later. We have a section where we'll go through this. Consider also installing the SQL Server IaaS agent extension on your SQL Server in an Azure VM. This is going to give you a lot of features here that can help you reduce your administrative overhead. It has the SQL Server automated backup. So this automates the scheduling of your backups on your VM. And then the backups are stored in Azure Blob Storage, if you recall. It also offers our SQL Server automated patching, which allows you to configure a patching window where these are windows of time that we're going to allow the updates on your VM to take place. And we only have SQL Server updates that are pushed down through the Windows update process. Those will be applied. Also, Azure Key Vault integration, which enables you to use Azure Key Vault as your secured storage location for SQL Server certificates, backup encryption keys, and other secrets such as the service account passwords. And we have other main features that you can see listed here are the Defender for the Cloud portal integration that we offer to integrate SQL Server on Azure VMs with Defender for the Cloud to monitor its security posture here and to receive actionable recommendations directly in the Azure portal. You can also view disk utilization in the Azure portal too, to easily track and analyze your SQL Server VM disk usage. And you can take advantage of flexible licensing options, which includes the ability to bring your own license to optimize the cost for SQL Server on an Azure SQL Server on an Azure VM. And lastly, you can deploy any supported version or edition of SQL Server on your Azure VM to suit legacy and specialized workloads. This gives us a lot of flexibility with the version and the edition. All you have to do is simply install the SQL Server IaaS agent extension to have all these options, automating backups, patching, and integrating with the Key Vault for enhanced security and simplified management. The extension allows you to view information about your server configuration too, and you can do it right from the Azure portal. So this is something you don't want to miss. You definitely want to add this extension in. It'll help a lot with management. If you're not part of the Microsoft Software Assurance Program, you can deploy a pre-configured SQL Server image from the Azure Marketplace using the pay-as-you-go model. This means that SQL Server license cost is going to be bundled into the virtual machine pricing, and you're billed per minute for usage, making it a simple and flexible option for many organizations. For those participating in the Software Assurance Program, you have more licensing flexibilities. You can still use the pay-as-you-go model, or you can bring your own license. And by deploying a VM here without the SQL Server pre-installed, this allows you to apply your existing on-prem SQL Server license to the VM. To stay compliant, you must also submit license mobility verification form within 10 days of deployment. You can install SQL Server manually or upload a custom VM image. Additionally, the Azure Hybrid Use benefit here lets you apply existing Windows Server licenses to your Azure VMs, further reducing the cost. So this is similar to how bring your own license works for SQL Server. So a lot of ways to save cost using your on-prem SQL and Windows licenses. Azure also offers a variety of virtual machine series. As you can see here, each of them are tailored really to a different workload that you might be running. When selecting a VM size for your SQL Server, it's important to match the VM's capabilities to your performance and scalability requirements. The general purpose series here provides a balanced CPU to memory ratio, ideal for development, testing, and small to medium databases or web servers. Compute-optimized VMs offer a high CPU to memory ratio, making them suitable for medium traffic web servers, batch processing, and certain machine learning workloads that don't require GPUs. Memory-optimized VMs deliver a high memory to CPU ratio and support up to 4 terabytes of RAM, making them a strong fit for most database workloads. For more specialized needs, storage-optimized VMs offer fast local storage, which is great for scale-out data workloads like Cassandra. Though SQL Server users should pair these with data protection features like always-on availability groups. GPU VMs are designed for graphic-intensive tasks such as video rendering and are massively parallel machine learning workloads. Finally, high-performance compute VMs support applications that scale across thousands of cores and require low-latency communication, thanks to RDM networking. Each VM series is fully detailed in our Azure portal, helping you choose the best fit for your SQL Server workload. Let's break down this information a little bit more about our Azure Virtual Machine series shown here. The A-series VMs are entry-level and economical. They're suitable for development and testing environments. The B-series VMs are burstable and ideal for workloads that experience periods of low activity with occasional bursts of performance. The D-series offers a balanced CPU to memory ratio and are suitable for general-purpose applications. E-series is optimized for memory-intensive applications, providing a high memory to CPU ratio. The F series is compute optimized, offering a high CPU to memory ratio, and this is ideal for compute intensive tasks. The L series is storage optimized, providing high disk throughput and suitable for applications requiring high input-output performance. The M series is designed for high memory workloads, offering the highest memory to CPU ratio. And the N series is GPU enabled and suitable for tasks requiring high graphical processing power like machine learning. And lastly on our list, the H series, which is designed for the most demanding computational tasks. Each series is tailored for specific use cases, ensuring that you can select the best option for your needs. So the one that I would recommend is the G series. It gives you the memory and the storage, which is what SQL needs the most of. Let's explore some key SQL Server configuration settings to help you optimize your deployment in Azure. When creating a virtual machine, the SQL Server Settings tab is where you define critical parameters. Under Security and Networking, you'll choose between private and public connectivity. Private is your intranet, and it gives us access to our SQL Server, exposing it to the virtual network and enhancing security, especially when using the default port of 1433, which you may want to change out. Also, what we'll see here is public internet access enables remote connectivity via a public IP, but it is recommended to change the default port there also to reduce vulnerability to automated attacks, because that 1433 is a very common port that everyone knows when we get connected to SQL. So that's the reason to possibly change that out, one to really think about. If your SQL Server supports external apps or users, enable SQL authentication. For secure key management, especially in production or compliance-sensitive environments, you're going to want to integrate with Azure Key Vault to automate key rotation, also to help you work with access control and auditing. In the SQL instance setting, you can customize the instance name, the collation, the telemetry options that are there, and you can align that with your workload needs. You can use the custom collation if you'd like. There's a multilingual app that you can enable. You can enable telemetry also for performance and monitoring. On the license page, be sure to indicate whether you're using an existing SQL Server license to take advantage of that cost savings we talked about before, which is up to about 43% with your Azure Hybrid benefit that you can use here. Finally, enable automated patching to reduce downtime and security risks, and automated backup to protect critical systems like your e-commerce performance sites where data loss could be very costly. These settings help ensure your SQL Server deployment is secure, efficient, and tailored to your environment. Suppose your organization has a significant investment in SQL Server infrastructure on premises and in local data centers. In that case, it's crucial to be aware that using the cloud isn't an all or nothing proposition. However, there are ways to use existing on-prem infrastructure in a hybrid capacity with Azure to help you improve your operational resiliency and reduce costs while offering some nice Azure cloud benefits. And we're going to see some of these coming up here. So implementing a hybrid infrastructure is also an excellent first step in evaluating cloud computing for your organization that has been traditionally on-prem, and maybe it's a little skeptical of getting into the cloud. So it's common for today's organizations to have a mixture of physical and virtualized deployments of SQL Server on-prem and in the cloud, or maybe a mix of both, as we'll see. The hybrid SQL Server platform offers the benefits of both on-prem and cloud services, and it's a complementary middle ground between the two of them. High availability is defined in Azure as recovery from within a region. Disaster recovery is defined as recovery across regions. So hybrid is the most common scenario for deploying SQL Server. Disaster recovery is used to ensure business continuity in the light of catastrophic events. Organizations may distribute deployments across multiple data centers for failover in an on-premise approach. These data centers typically reside within the same geographical region as the organization. Thus, it's susceptible to the more significant regional disasters. Physical data centers are also costly to deploy, monitor, and maintain. Arguably, the cost of spinning up an Azure SQL virtual machine in various geographical regions is much less than establishing a new physical data center in another geography. So using hybrid scenarios for SQL Server disaster recovery offer key benefits by combining on-premise infrastructure with cloud-based resources. This setup enhances reliance by enabling failover to Azure in case of a local outage. And it also supports geo-redundancy and reduces recovery time objectives, or RTOs. It can be used when replicating critical databases to Azure using always-on availability groups, maintaining standby environments for business continuity, and also leveraging Azure Site Recovery for automated failover. Hybrid disaster recovery is ideal for organizations needing high availability without fully migrating to the cloud. In a hybrid SQL Server scenario, backups involve storing or replicating on-prem SQL Server backups to the cloud, typically Azure. For added resilience and flexibility, this approach provides benefits like off-site storage for disaster recovery, long-term retention, and cost-effective scalability. Common use cases for this include backing up critical databases to Azure's blob storage, using Azure Backup for automated protection, or even integrating with Azure Site Recovery for full VM-level backup and failover. It's ideal for organizations that want to enhance their disaster recovery strategy without necessarily migrating to the Azure cloud. In a hybrid SQL Server backup scenario, Azure Storage plays a key role by providing scalable, secure, and cost-effective off-site storage for your database backups. You can back up on-premises SQL Server databases directly to Azure Blob Storage, which supports long-term retention, geo-redundancy, and integration with tools like Azure Backup or SQL Server Managed Backup. Specifically, Azure Storage can be used to store on-premises SQL Server data files for user databases. Note that these are user files and not system databases. In the case of local storage failure, user files are safely stored in the cloud, preventing data loss. In addition, by using Azure Storage, there are built-in reliability guarantees. So storing these files in the cloud is more resilient. For this hybrid scenario, it's essential to keep the network communication secure, evaluate the network latency of the solution, and ensure the storage account is locked down using ACLS and Microsoft Entra ID. Azure Arc-enabled SQL Server is a hybrid solution that extends Azure management and governance capabilities to the SQL Server instances running outside of Azure, whether they're on-prem, in other clouds, or at the edge. Azure Arc allows you to register and manage your SQL Server instances through the Azure portal, enabling really that centralized visibility, policy enforcement, advanced features like security auditing and tagging, and more. It enables the inventory of all registered SQL Server deployments and assesses their configurations, their usage patterns, and the security to provide actions and recommendations based on best practices. Use it to apply Azure policies, track compliance, and enable Microsoft Defender for SQL. It integrates with Azure Monitor, Log Analytics, and Azure Policy for consistent operations. It also uses Azure Defender's real-time security alerts and vulnerability reporting on both on-prem SQL servers and their host operating systems. And you can also couple this with Azure Sentinel for security threat introspection. To summarize, use it for disaster recovery, compliance, auditing, inventory, tagging, and cost optimization. Each Azure SQL virtual machine includes at least 2 disks. It has an OS disk, which is the C drive. It has a temporary disk, which is the D drive. And then the OS disk is persistent and stores the operating system, also SQL Server binaries and the system databases. For production environments, using premium SSD is recommended to ensure that you have a very fast boot and SQL startup times are faster. The temporary disk, on the other hand, provides an ephemeral storage ideal for placing temp DB, which benefits from its high IOPS. However, since data on this disk is lost upon virtual machine deallocation or restart, it should never be used for critical data. You can also attach a data disk, which is usually an F drive and later, to store user databases, logs, and backups. These are optional but essential for scaling storage and performance. For high throughput workloads like OLTP or data warehousing, premium or ultra SSDs are ideal. Azure offers several storage types. Standard HDD or very cost-effective for dev and testing environments, standard SSD for moderate performance, premium SSD for production workloads, and ultra SSD for mission-critical applications. Using managed disks is recommended as Azure handles all the provisioning, the redundancy, and the scaling, hoping to simplify your deployment and enabling integration with availability sets, zones, and backup tools. Separate data and log files place data files, MDF files, and transaction log files, or LDF files, on separate disks. This is a best practice. This reduces the I/O contention and improves performance. Enabling read caching on data disks also will help to accelerate read operations and disable caching on log disks to ensure write consistency. Stripe multiple disk for performance to scale IOPS and throughput beyond a single disk's limits. Stripe multiple disk using storage spaces, which is inside Windows, or Logical Volume Manager, LVM, which is in Linux. This is especially useful for high-performance SQL workloads that require large volumes or faster disk access. Table and index partitioning in SQL Server is a powerful strategy for improving performance and manageability of large data sets. By dividing a table into smaller logical segments called partitions, SQL Server can scan only the relevant partitions during queries, reducing I/O and speeding up execution. This is especially effective for time-based data like logs or transactions, where queries often target specific date ranges. Partitioned indexes align with the table structure, making maintenance and lookups more efficient. To implement partitioning, you follow 4 key steps. First, create file groups to define physical storage locations. Next, define a partition function to specify how data is split. It's typically by date, but you can change that out to however you'd like to. Next, you want to create a partition scheme to map partitions to the file group. And finally, you want to create the partition table using that scheme. For example, you might partition data by month across different file groups, allowing SQL Server to store and query each month's data separately. This setup is ideal for scenarios like reporting or archiving, where targeting specific partitions will help improve performance and simplify maintenance. The example shown here demonstrates how to partition a SQL Server table by month for the year 2021 using a partition function and a partition scheme. The function partition by month uses range right to define a monthly boundary based on the order date column. Each partition includes dates greater than the specified boundary, allowing SQL Server to efficiently organize and query time-based data. The partition scheme partition by month scheme maps each partition to a separate file group, like file group 1, 2, and etc., physically distributing data by month. The order table is then created using this scheme with partitions aligned to the order date. This setup is ideal for scenarios like reporting or archiving, where queries can target specific months, boosting performance and simplifying maintenance. SQL Server offers several data compression options that help reduce storage footprint and improve performance by minimizing I/O. Each method is optimized for different workloads, from OLTP to analytics, and can significantly enhance query speed and resource efficiency when used appropriately. Row compression reduces storage by eliminating unnecessary metadata and using efficient data types. It improves I/O performance with minimal CPU overhead, making it ideal for OLTP workloads. Page compression builds on row compression by adding a prefix and dictionary compression at the page level. It offers greater space savings and can improve performance for read-heavy workloads, though it uses slightly more CPU. Column store compression is optimized for analytics and data warehousing. It significantly reduces I/O by compressing data in a columnar format, enabling faster scans and aggregations. Column store archival compression applies even more aggressive compression to the column store data, and it's ideal for cold or infrequently accessed data. It maximizes storage savings with minimal impact on query performance for archival scenarios. Inline compression uses the compression function to reduce data size at the row level during inserts or updates, and it's useful for compressing individual values, especially in scenarios with large text or binary data. Optimizing SQL Server performance requires more than just hardware. It involves fine-tuning configuration settings and maintenance practices. The recommendations on this slide focus on improving efficiency, reducing I/O bottlenecks, and ensuring consistent performance across production workloads. These adjustments are especially important in environments with high transaction volumes or complex query patterns. Key performance enhancers include enabling backup compression to reduce the I/O during backups and instant file initialization to speed up data file growth. Also, moving databases and log files to a dedicated data disk helps to isolate the I/O and improve throughput. Disabling auto shrink and auto close will also prevent unnecessary overhead, while setting a max memory limit and enabling lock pages in memory ensures SQL Server uses memory efficiently without starving the operating system. Additional recommendations like enabling query store and optimize for ad hoc workloads will help you to improve query performance and plan reuse, especially in OLTP-heavy systems. Regularly scheduling SQL Server agent maintenance jobs and monitoring transaction log health will also ensure long-term stability and prevents performance degradation. Together, these practices create a well-tuned SQL Server environment capable of handling demanding workloads with greater reliability. High availability and disaster recovery are critical components of a resilient SQL Server deployment on Azure. This slide outlines 3 key Azure native strategies that help ensure SQL Server remains accessible and protected against various types of failures. Each option addresses a different level of fault tolerance, from local hardware issues to full regional outages. Availability sets provide protection against planned maintenance and unplanned hardware failures within a single data center. By distributing SQL Server VMs across multiple fault and update domains, availability sets reduce the risk of simultaneous downtimes, ensuring that at least one instance remains operational during maintenance or unexpected outages. Availability zones distribute SQL Server resources across physically separate data centers within a region, safeguarding against data center level failures. Paired regions extend this further by replicating data and services across geographically distant regions, ensuring business continuity even in the event of a regional disaster, while maintaining compliance and data residency requirements. Together, these strategies form a layered approach to SQL Server HADR on Azure, enabling organizations to meet uptime SLAs, minimize data loss, and maintain service continuity across a range of failure scenarios. Availability sets in Azure are a foundational high availability feature designed to protect SQL Server workloads running on virtual machines. By distributing VMs across multiple physical servers, also known as fault domains, and scheduling updates across different update domains, availability sets help ensure that not all instances of a SQL Server's deployment are affected by hardware failures or maintenance events at the same time. For SQL Server, this means that critical services such as database engine, SQL agent, and reporting services can remain available even if one virtual machine goes down due to host failure or a planned update. This is particularly important in multi-VM deployments using features like always-on availability groups or failover clustering, while maintaining quorum and minimizing downtime are essential for business continuity. The diagram on the slide illustrates how VMs in an availability set are distributed across fault and update domains within a region. Each is connected to a managed disk in a storage cluster. This separation ensures that both compute and storage resources are resilient. In SQL Server environments, this setup supports consistent performance and availability, making availability sets a key component of a robust HA strategy. In summary, availability sets provide a simple yet effective way to increase the uptime of SQL Server VMs in Azure by isolating them from a single point of failure. When combined with other HA and DR features, they help ensure SQL Server workloads remain reliable and responsive under a variety of failure scenarios. Azure Availability Zones enhance SQL Server and Azure SQL Database resilience by distributing instances across physical separate data centers within the same region. Each zone has an independent power, cooling, and networking option, helping protect against data center failures and supporting a 4 nines uptime SLA. While there may be additional costs from the intra-zone network traffic, the benefits are significant, especially for mission-critical workloads. SQL Server benefits from availability zones through a high availability, synchronous replication, disaster recovery, and scalability. For example, using an always-on availability group, you can place primary and secondary replicas in different zones, ensuring seamless failover with no data loss. Best practices include deploying zone-redundant Azure SQL, configuring automatic failover, and monitoring latency to ensure replication meets your performance SLAs. This setup is ideal for applications like e-commerce or financial systems that demand high uptime and reliability. An Azure region is made up of multiple data centers connected by a low latency network designed to deliver optimal performance and security for services like SQL Server and Azure SQL Database. These regions exist within a broader Azure geography, which help maintain data residency and compliance. This is critical for regulated industries using SQL. Within each geography, Azure defines fixed regional pairs, such as East US and West US, which offer built-in advantages for SQL workloads. Platform updates are staggered between the paired regions to reduce downtime risks, and in the event of multi-region outage, one region in each pair is prioritized for recovery. This setup benefits SQL deployments by enabling geo-redundant backups, active geo-replication, and disaster recovery strategies that ensure database continuity and also protect against data loss. By leveraging paired regions, organizations can architect resilient SQL solutions that meet both performance and compliance requirements. Here we see the architecture of the always-on availability group in SQL Server, a high availability and disaster recovery solution built on Windows Server Failover Clustering, or WSFC. In this setup, a resource group, MyAG, spans multiple nodes, each running on a SQL Server instance, with one designated as the primary replica and the others as a secondary replica. What you will see is transactions are committed to the primary and then replicated to the secondaries. It does this either synchronously within the same Azure region or asynchronously if we have to go across geographical regions. This design benefits SQL workloads by ensuring data integrity, automatic failover, and read scalability. Synchronous replication provides zero data loss during failover, and it's ideal for mission-critical applications, while asynchronous replication supports global disaster recovery. Always-on availability groups can be implemented across 2 to 9 SQL Server instances, whether it's hosted entirely on Azure SQL virtual machines or in a hybrid configuration spanning on-prem and cloud environments. The physical distance between the replicas determines the appropriate availability mode: synchronous for low latency, intra-region deployments, and asynchronous for geographically dispersed setups. Importantly, this solution protects a group of databases, not the entire SQL Server instance. It allows for more granular control over high availability if you'd like that. A best practice would include to place the synchronous replicas in different availability zones for fault isolation, using asynchronous replicas in a paired region for geo-redundancy, and then configuring automatic failover policies here to minimize downtime. More on high availability and disaster recovery in our last section of this course. Azure Backup for SQL Server is a comprehensive enterprise-grade solution designed to protect SQL Server workloads running on Azure VMs. It offers long-term data retention, automated backup management, and enhanced data protection, making it ideal for organizations with strict compliance and recovery requirements. Unlike basic backup methods or the Azure SQL Resource Provider, this solution provides a richer feature set, including point-in-time restores, auto protection, and centralized monitoring. To enable automatic backups, an agent must be installed on the virtual machine hosting the SQL Server. This slide shows how the backup process integrates with the Azure service, using components like the workload backup extension and the recovery services vault. It supports a 15-minute RPO, helping us meet stringent recovery objectives if we have them, which I'm sure we do. And then remember to make sure that the agent is properly installed and configured, regularly reviewing the backup policies and retention settings, and make certain also to monitor the backup health here and alerts from your central dashboard, making certain the backups are going through. Azure Backup for SQL Server can be used in enterprises that need reliable long-term SQL Server backup, organizations with regulatory requirements for data retention, or with workloads requiring frequent recovery points with centralized oversight and more. Azure Site Recovery, or ASR, is a low-cost disaster recovery solution that performs block-level replication of an Azure virtual machine. It enables organizations to test and verify the disaster recovery strategy, and it's particularly effective for stateless environments like web servers, where a high recovery point objective, or RPO, of up to an hour is acceptable. This slide illustrates ASR's replication flow from registering the VM, replicating data to cache, transferring it to a target storage account, and finally adding the VM to the target environment during failover. While ASR is less ideal for transactional database workloads due to its RPO limitations, it can be used for availability groups to achieve lower RPOs. It's also well suited for a migration scenario where some downtime is permissible. Best practices include validating replication settings, regularly testing the failover procedures, and using ASR in conjunction with other availability features here for critical workloads. As you can see, Azure Site Recovery offers a flexible and affordable option for disaster recovery and migration, especially when paired with complementary technologies to optimize performance and minimize downtime. Now it's time for our knowledge check. Question 1. What type of storage offers the lowest latency in Azure? Answer: UltraDisk. Question 2. Which option should you choose to spread workloads across data centers in a region? Answer: availability zones. Question 3. To reduce the cost of an Azure SQL virtual machine you intend to run full-time for 3 years, which option should you choose? Answer: Azure Reserved VM instances. Now let's take a look at how to provision a SQL Server on an Azure virtual machine. Hello and welcome to Lab 1, Provision a SQL Server on an Azure virtual machine. So we're going to get started here using the Azure portal. But before we do that, I want to show you how you can get access to lab exercises and files from GitHub. So what I'm going to show here is we can see all of the DP-300 administering Microsoft Azure SQL Solution Lab files here. These here are where you can set up your own environment. You can also go in and get into each of the labs. So these are the instructions, and you can click here and you can see the instructions. You can click here and set up your environment. Here's the URL, it's right up there. All of this comes from GitHub, so this is a nice option here to use. The other option is you can go directly to GitHub and download all of our lab files and instructions for the DP-300 Database Administrator here. It's under Microsoft Learn, and if you zoom in to that, you will see the address right here. You may also want to get yourself a free Microsoft Azure account. It's good for 30 days or for $200 for 30 days. And you can use it to help you in order to get access to the Azure portal, and particularly SQL and Azure. So once you see that, we have it here in the portal. So now we can get your Azure account, and you can get the instructions, and you can follow along with what we're doing. I'm going to go now into the Azure portal. And in portal.azure.com, I'm going to use this Azure SQL. This is a great option to use. It has all the features that we want to create for this class. You can use it to create a lot of things, the database, the managed instance. You can also use it to create the virtual machine. And if you don't see it here on our list of services, you can always go up to the top and search and type Azure SQL and grab it from there. You might also want to go to the portal menu and maybe add it in as one of your favorites to the list. So that could be helpful. So I'm going right now into Azure SQL here. And what I'm going to do is, you can see I have a number of virtual lab machines here and labs that I've used. These are in different sites. It takes a bit for it to process, so I want to show some of the different sites. And I have some of these here, but I'm going to do this as I'm going to click on Create. And here's where I can make a SQL database, an elastic pool. I can also do a database server. I also here can make a managed instance, and there's different options there. So if I click on Show Details, it kind of gives me a little bit more information about each one. There's the SQL database, there's the managed instance, and what I'm going to do is I'm going to use a virtual machine. Now the virtual machine has images already available for us to use, and I'm going to actually use the one right here, but I do want you to note that there are different versions to use. If you'd like, you can go as far back as SQL Server 2016 on the list, and if I scroll all the way to the bottom, I can see the Service Pack 2 option, but you can also work with other operating systems like Ubuntu and Red Hat Linux. So I'm going to choose simply this one right here as part of our lab, and I'm going to click on Create in a moment. I can also choose the checkbox for high availability. This is an excellent option, especially if I want to create high availability, why I can make it built into my virtual machine. So we'll talk about high availability coming up, but as I click on Create, you can get in and you'll be able to see the virtual machine and all the tabs, most of which we're going to choose just simply the default options, but it's based on your subscription here. And then we have to have a resource group created. Now you can create a new one, or you can choose one from the list if you already have one created. And then you have to create a virtual machine by giving it a name. So I'm going to go ahead and pop this name in here. And this is going to be my Lab 1. And we're going to go with Lab B, Lab 1B then. Notice the region. So this region is where my resource group is at. And this region is a region, hopefully, that's near me, but you should pick one that's near you. Now, I'm not going to use any of my availability zone options here where it's not really called in for the lab, but in real life, you might want to put it into your availability zone or set. More on that in our upcoming lectures. You also have a defaulted option here for the security type. I'm going to leave it at that. If I wanted to change out the image, I could see other images right here. And then as I scroll further down, what you will see is I could go in and adjust the size. So this is the one I'm going to use, but there's other sizes that are available that I might want to work with, so I can choose other sizes if I'd like, and to do that. And it really depends on my workload, but the size I'm going to choose right now is at least 2 virtual cores, 8 gigs of RAM, and the one that has 4 data disks and the max IOPS of 3750, which isn't too bad here. So I'm going to keep this one selected. And then you'll also note that you can come down here and you can go and create an administrator account. This is the one I'm going to use right here, and I'm going to put in the password. And hopefully they match and meet the requirements there. It will tell you if it doesn't. And then notice that it's going to do inbound port rules. So I'm going to allow the selected port here. This is DP-300 that it's working with. And you'll also see that we can bring our own licenses. So if you have a Windows Server license that you use on-prem, you can use it here for the hybrid benefit and then use it to save some money. The RDP port 3389 we're going to be using to get connected. It's our default port. Now it's going to make some recommendations, and I can use these recommendations, or I can just say, no thank you. But if I found something similar that I want to consider, and I'm not going to go and do it, I can adopt it if I'd like. It'll have other suggestions. And I'm just going to go right here. And now I go into the network tab to the disk section, and you can see the disks that it picks. So there's different sizes you can choose from. And maybe I want to go with something smaller, although I think this is the smallest one I can choose from here, or bigger even. And then it can be premium. This is locally redundant, but maybe we want to change that out for our production service. A good idea with that. I'm just going to go with the defaults. But you need to keep in mind the options that they're showing us are based on the SKU that we currently have for our virtual machine. So different SKUs will have different options. And I'm going to click on networking, and it will pick, it'll create a new network for you. And it will also usually create an IP address for us. So normally that's the case. It picks an IP address so we can create a new one if we need to. It will also do that virtual network. It creates a new one, creates a subnet. It's likely also going to open up the port here for RDP. So usually you can go through the defaults and use those, but you may need to create a new IP address for this one, like I'm going to do right here. Notice that I can tell it what kind of address I want, and I can also set up the routing preference to the Microsoft network. I can also adjust it so I can usually pick up the right ones for us here. Then under management here, I can have it use a system assigned managed identity. That's usually for an app or service to get connected. Microsoft Entra is for us to get connected using RBAC with Azure here. We'll talk more about Microsoft Entra and some of the identities later on. And then you'll also note that I may want to have it automatically shut down at a certain time. Now I can have it do that by enabling auto shutdown and give it a time to shut down, especially because it's on development. And I'm not going to use this for, more than 24 hours in a day. So I may want to save compute costs by having it shut down. And we'll do enabling of disaster recovery a little later in our course here too. And then you can also adjust, and there's a lot of things that we can come back to if we need to. I was going to go in and do the health monitoring with all of this, so we'll talk about that in a later learning path, but you have a lot of options here you can choose from. So now I'm going to go into advanced, and we can see maybe I want to add some apps. These apps will help me to manage the virtual machine. There's a lot that I can add to this, but our main option here is we're really going to go out and work with the SQL Server settings. So right now it's set for communication within the virtual network. That's the port it's going to use. I could enable SQL authentication here too if I wanted to do that. I could also enable the key vault. So if I have secrets and keys I'd like to store, that's a good place to do it. We'll talk about that in our security section. But I do want to configure storage. So this is the system being used for development. I don't necessarily need it to be the largest disk available here. So I'm going to make it a smaller one of 8. I'm also going to do premium, although I could adjust it. And what you'll need to note definitely for production, go as high as you can for this for performance reasons, of course. But I'm just going to go in and work with my SQL Server database here on the G drive. So under the folder called Data, I can change that if I'd like. And my log storage here is also going to be on a separate drive for logs, excellent for performance. I can change the log path, and then here too, I can adjust the disk type. And I'm going to reduce it back down to 8 gig there. And then my temporal database here, I'm going to also keep the default best practice here of putting it on a separate drive for TempDB. And it's going to create that on the H drive and with that folder name here. And then again, you can see the disk that it's going to be using, and I'm going to go down again on this one to 8 also. So we've set that up, and here you can see I can configure even more options. So these are the best practices that the TempDB file using 2 files is based on this, based on the 2 vCores of the virtual machine. But we can go up to 8 if we needed to. So it already sets it in for the best practice. And I'm going to go ahead and OK this. And then I can look at some of the other settings that we have control over. changing the correlation, adjusting the maximum degree of parallelism. There it's 0. Let SQL manage it as it sees fit is that 0 option. You can adjust memory and other optimization options as you see fit too. And I'm not going to make any changes. I'm just going to pick the defaults there. Now this is also where I can bring my SQL Server license in and take advantage of that hybrid benefit to save some money. I can adjust the patching when I want it to occur, the backup when I'd like that to happen, and other things as you can see from here. Consider also tagging so that you can keep track of maybe the department, the region that's using it. Maybe we also want to enter in the cost center to be able to charge back. There's a lot of good options there. And I'm going to review this, and I'm going to see if I can get it to validate, and if there's any issues, it will tell us what it finds. So if there have any issues, I can go back to the red dots and make, it'll be on the different tabs, so I can make certain that I fixed it all so we can pass validation. I can also scroll down the list here and just, take a look at the settings that I picked to make certain that they're the ones that I want. This is the process of creating the virtual machine, but I can make changes here to the settings as I see fit. And as I look through the list, I think I'm ready to go. So I'm going to click Connect and go ahead and have it process it since we hit Create. And this is going to take a little bit of time. I have a couple of different virtual machines here in different states to show, since this will take a little bit of time to run. So the deployment's in progress. It shows where it is created. You can see the template, the JSON template that creates. You can download this, you can deploy that template, you can copy it, you can make modifications and deploy it to other things if you'd like. So every resource you have in Azure has this created template, and you can go to that template and you can download it and reuse it if you'd like. So we're going to let this run for a while, and I'm going to go to another virtual machine that I'd like to use that is already started, and all I need to do is connect to it. And one of the other options I could consider is connecting via Bastion, but I'm going to connect by hitting Connect here, and we'll go out to the Connect tab, and then what you'll see is I can download the RDP file, and it gives me a little warning here telling me that this could harm my device. I'm sure I want to keep it. Well, I know I requested it, so it's my VM, and I'm going to go ahead and click on it, and then I'm going to go ahead and open the file, and it will take just a moment to open. And it's likely going to open up on my other screen, and it has, so here it is. I want to get connected to it right here, and I'm going to go ahead and click Connect, and then I'm going to open it up on my other screen, and it's going to ask me for the password again. And so when we created the DP-300 admin, we created it with a password, and now it's time to remember that password, and hopefully we can get connected to it. And then it's going to give me another screen here. It's a little bit of an issue with the certificate, but I'm going to go ahead and say yes, get connected to it. And then it's going to open up into another screen here that I will show. And it usually takes you right to the Server Manager, where you can take a closer look at what's going on with your virtual machine here. So this is a nice option. But when I want to do this is, what I want to do is I want to open up the Management Studio. So I'm going to type in SSMS and click on the SQL Server Management Studio. Then I'm going to open that Management Studio. And what we can do under Connect and Database is connect to that server that we just created. And then we're going to go in and authenticate using Windows. And then we can see here, we're going to want to work with that certificate. And once we do that, it will connect us, and we can see our system databases right here. Now, we don't have any databases on it just yet, so stay tuned. We may add a few more as we go forward. So hopefully you enjoyed this section. Hopefully you really had some good ways here that you can roll out, and hopefully you can able to follow along what we're doing here with the lab files and set up your own virtual machine. In this section, we explored the essentials of running SQL Server in an IaaS environment using an Azure virtual machine. We covered how to deploy and configure SQL Server, optimize performance and security, and implement high availability and disaster recovery solutions. Thanks so much for joining. See you in the next section.